Share. Yeah. Let's read right side.
Roll F5.
Right team.
Hey. Cool. So, like I said, my name is Mike, and I'm going to talk about working with the legacy code. Something that is very near and very dear to my heart. I don't know how that happens. It just seemed amazing. So I don't know how that happened. A lot of projects I've been on just happen to have been legacy code, and just the first time I found a way to take myself out of it, I learned some tips and tricks, and then I found a book that I mentioned worked with legacy code. So I've kind of taken, this is going to be like a Cliff's Notes version of what's going on in that book. So if you want more details, I'm not selling it or getting it. So first basic question is, what is legacy code? Anybody have any ideas for this quick subversion of submission?
Old functionality.
Okay.
Brownfield development.
Brownfield development. Okay, I've heard that one before. Okay.
COBOL.
This is my definition is code without tests. Any code without tests, I don't care how old or how young it is a legacy code. But the nice way to say that by this book is any code that we're not confident in making change. And that's really what tests do for us. They give us the confidence to go in there and make change. I mean, who has walked into a codebase and there's no documentation and there's no tests and good luck using your stories and so we should fix this button. And you're okay. So yeah, when you go find a line and you don't know what's going on, you don't know how many threads are involved in that. You go to fix it. But you say, okay, and it's a typo. Somebody just forgot to add, a semicolon in an inline SQL query here. Well, what are these fixed? A week later, you get a call, production's down. Always inflates your hotfix. What happened? Well, you changed something, and there was a side effect, and you didn't know it. You didn't have any way to know it. Now what are you doing? You're racing right back into that piece of code, and you're trying to put another patch on top of the patch that is probably on top of a mountain of patches for everybody for you. And you don't know what's going on. You don't know what it is, and you don't have any confidence that you're making change, and that changes. So, how do we do it? I mean, pretty straightforward. We add tested code, which immediately leads to the next question. But I can't test this. This is untestable. I have an application that expects to be running on Windows CE in the year 1999 in Albuquerque, New Mexico. How do I mock that? Okay, I'm not going to cover that case. Sorry. I said this is a Cliff's version. But the basic pattern that you take is, step one is, you don't try to blow the whole ocean. You don't try to change it. You might want to. Believe me, I have. But you first identify a portion of the system you want to change, a snippet of the code, something that looks just one little thing. You have the bug report. You identify, say, the 5 lines in the system where the bug report is. Okay, you've identified the portion. Then step 2 is we use what I like to call a safe refactor to isolate that. So a safe refactor is any kind of refactoring that we can do that doesn't introduce side effects or change the system. Depending on where you are, what language this is, it's going to be a very, very, very limited set of tools. And this is probably the most important part, is you've got to restrict yourself to the tools that will not cause problems. And I'll go over 2 basic refactoring patterns I use and how I have something to tell me refactoring is going. But key is you don't just go in there and copy paste or pull out code. You have something that will tell you instantly broken. So once we have refactored the code, you TDD it. I mean, that's you extract the 5 lines out. You have 5 lines. It's really, really straightforward to do test-driven development on just 5 lines of code. Then go back to the beginning, find the page of the code, repeat, and keep on going until you slay the giant by cutting it down by bits. Okay. It's not quite that simple. And I'm going to go through I'm going to give two quick examples here. So the first one that I call that on the left is called the extract method. And that's, everyone's probably familiar with this. Most people's IDEs have like a refactor right there that says extract method. You type the code, you can extract method, and there you go. The key about this is most IDEs are going to use static analysis. So there's side effects. If there's parameters you don't know that are being touched, it's going to tell you. And this is probably the most important part. If you do not have a static analysis tool set up for your language, go get one. And if you can't, the follow-up is to find a way for your compiler to break irreparably when you decide to. I use, even in Python, I'll use Python and also MyPy to kind of get at some level of type safety and, I'll even start off by putting just an end-to-end test around my tag, just one instance. The lights turn on, yeah. But I'll start there because if I break an extract method, people tell me. And of course, whenever the IDE does this for you, you have to double check what's going on. You might do extract method and find there's 15 other parameters in the method that extracted. Those are side effects. You need to think about how you're doing it. The other one is pattern, and you call it, it's actually this comes from like the finish book, it's called breaking seams. So a lot of the times, you're dealing with legacy code, you have a lot of stuff that's entangling, a lot of stuff that is importing just freaking everything. How do you do that? Well, the first is you identify what he calls our seams. And these are places where you can break just ever so elegantly, where the code is stitched together. Use a seam breaker. One of my favorite ways to do this is just by looking at the imports. Now, everything imports something. And you'll find, like, you'll say you have a dot class, right? It has 50,000 methods, and that's what they do. But these 10 use this import. These other 10 use this import exclusively. Guess what? There's a seam between those two. We can extract those. The nice thing about this one is it's really as simple as many IDEs give you a refactor move to do this with logic static analysis tools. But if you just move the methods out to a new class, as long as there's a runner there that can check it, the compiler runtime will break as soon as you mess that up. Okay, now these are the tools I'm going to try to trick myself to. Oh god. See if I can get all this to work. All right. Where is my mouse? Oh, there it is. So go over here. Get out of the screen mode. I'm trying.
You should try pushing this thing.
Hey! Hey, there we go. Okay, cool. And just go to Backend flowers. Hey. Let's see if I can make this bigger. All right. Oh god, I can barely read this. Yeah, is that gonna work? Nope. Let's go here for that. I apologize for you. It does say it's a full plus. I'm trying. There's actually. Yeah. That's that. Is that one more?
Yes.
One more.
More. I've got young eyes.
I'm trying, man. There's like a 2-second lag between this and the other one. And one more. How about that? Hey. I like it. Hey. All right. Thank you all for bearing with me. I'm dying, so if I can do. All right. Let's just do this. Okay. So the dealio is, now I just wanted to write a simple message to the app. And the dealio is, well, we read a lot of tutorials about testing editor code. Code looks like this. Hello world. It says hello to the world. Great. The problem is code in the real world never looks like this. Let's see if I can do this. Nope. All right, let's try that again. Code in the real world usually looks more like this. And you know, I picked up Flask because actually Flask tutorials are pretty bad about just throwing everything in your main application everywhere. So I kind of wanted, well, this would be a great way to demonstrate what's going on. So what I'm doing here, if you can take a quick look, I'm doing a bunch of Flask stuff. I'm going to try to send a message today. Made a little database that holds some complete messages that hold that fortune. That's what that is. After you install it, and just try to load it up when the application starts up because why not? So this, it works, right? Somebody asked me, well, what does the code do? I mean, I can say, hey, the server seems to come up, and hey, right, I'm done. That's it. Where's my money? I'm good. No. The next person's going to hate me for that. Okay. So, kind of going back, I've got tons of things in here. I've got like the database definitions right here in the thing. I want to do something. So, what's the first thing I'm going to do? Well, first thing I'm noticing, if I go over here to line 20 and take a look at these guys, is I've got this stuff that's like X database here, and then I've got this nasty bit, which I do. If somebody wants to put a public quotes on the thing, I want to read it in, but this is right there in my name. I want to get that for you. So, what I'm going to do is I'm going to go ahead and try to extract it out. It would please. Come on, refresh. There we go. All right, so I've extracted it out to this little method below quotes. There it is right there. But there it is. Now I have this nice little method. Oh, I'm sorry, very, very first thing I did. Just refresh. End-to-end test. I'm not locking anything, I'm not testing anything, I'm running the entire application by end-to-end test. What am I asserting? That it comes up. I don't care if there's something in the database, I just want something good. And if I go oops. I swear this was working earlier.
Did you test it?
Probably rebased it. Actually, probably do a rebase against this. Oh, we don't have both quotes. No. I'm not using universal either. So I'm just going to cheat that. Okay, that's this is what I get for
Almost dying.
almost dying. Yeah. So let's pretend the test worked.
I do that every day when I'm doing
That's why I do with my legacy code.
Yeah, I can't quite see what's going on. I messaged something with my virtual VPN this guy, so it's not my pet. I apologize for that. But yeah, so I have, and I'm just using PyTest here, and I'm like, okay, let's test this with quotes. Let's test it through. And now I can mod things. It's clear what I can use to mod what's going on. I'm not trying to mod the whole world. I'm not trying to mod my internal application setup. I'm just trying to mod my database. Y'all kind of know how to do it. And just a whole thing. Cool. Let's go again. And let's try one more. And just keep on going, repeat, extract. So, and if I go back and look at my tests, cool, I've got like so many tests. I've got a test on loading quotes. I've got a test in fetching the quotes. I've even got a test on my Google random utility function, which apparently is just supposed to explode when it can't find anything. Cool. I'm done, right? This is great. My code's also done. I got 100% test done. No, not quite done yet. Because who here thinks this code looks better than when I started off with? Significantly though?
It's paragraphs instead of essay.
It is paragraphs of an essay, but it's still one big mess. I still have a bunch of things. So this is where, once we have my test servers, this is where we start to get home with refactor. And now I can start to find seams. So you might have noticed I have a couple methods here that are messing with database stuff, almost exclusively. So let's take a look here. So the first thing I did, that was major boo-boo, was I just threw everything in the main module. Which you shouldn't do. And okay. So we gotta first reorganize this into a proper application. Let's have a package. Let's have a proper Python package. And all I'm doing is I'm just moving my main module to my proper Python package. Cool. What's the advantage there? This is just Python organization. Let's go. Now, what do I have? This is my main method. So now this, who can tell me what this method does, or what this module does, what's its responsibility, right? This is now just dealing with HTTP stuff. Now, I have wonderful little database package with all the database stuff in there. Has a nice little home. Okay, and because I had tests and everything around this, I just moved this and be like, we go look at my tests. The biggest change I have in the previous one is I had to update all my package names. Test run will just instantly tell me that. So let's just play that game again. Let's refresh. Utilities and utility package. And as I described, usually with my utils, these are pure functions, right? I don't want things that are going to be hard to test and hard to work with. And all of a sudden, I can have a clear place where I'm testing. Post exception, I don't have to mock anything in this. I'm not importing mock in it, and that's probably the biggest giveaway. It's like I'm not even my imports and my tests are clear and concise. Point. And now if I go back to main one and check out 2.0, that's not over. Let's really shake it. Run it. And that's the wrong way. And it still works. Now I have tests, and now I have it, and everything is. So, kind of getting back to wrap this up. There's the. So to wrap things up, first, the very first step I usually take is to get to some sort of test around the whole thing. And you don't care about how good it is, you just want it to pass the system. Use that as just some way to tell you so you just track everything out. And then you're going to wind up with a whole mess of methods usually. And when you do, follow the imports. All the database imports from the database module. All the utility imports, if they don't import anything else, go to the utility module. And your main application entry point looks like main application entry point. There are so many patterns and more in what makes purpose working quickly with this code. I do recommend reading it. And he references in that book, Mark Fowler's book, Refactoring Improving Design of Existing Code, which goes deeper and deeper into factoring patterns. I wish I could take claim for these ideas. I can't. I'm confident. I just listen to people smarter than me. So, that's it.
When you refresh the page, I didn't see your app doing anything different. What's the value proposition?
Well, there's so many things wrong with that question. We don't think we can. So, if I had a little bit more time and also understood how form params work in class better, I actually would have gone. The next step would have been, what if I want to add a form where the user wants to add a to the database? Now, you could have easily done that in the original codebase. But then there would have been a parallel change in my load codes, and there would have been a duplication code. And so something I should have done a 3-line change is mistakes. Now, take that, scale that out to a feature request that is going to touch several modules and several files, and potentially several systems. And you're talking about just in a simple case like that, you're doubling that. So the value proposition of refactoring is that I don't break anything. I deliver the system exactly how it is. The value proposition of refactoring itself is, and I've seen this time and time again, is all future work is going to be delivered faster and more reliable, and easier to test, easier to upload.
I see what you said you use TDD to create testing. But in this case, how you integrate the testing using using TDD as a way of product?
It's not going to be pure TDD because obviously there's a lot of existing code. So it is what I did when I factored out the database stuff. I factored it out in the same commit. The closest I get to TDD is the same commit where I'm refactoring it. I then added test cases, right? And I'm getting that test coverage as for something that's a utility module like that as close to 100% as I can, which I don't Python bad one we see. So it's not going to be the pure classic TDD, but it's still going to be that you do not proceed next step without tests for what you did, right? So don't go work on I worked in database. I didn't start working on the utility stuff until I had tests on database stuff. So yeah, not true form, but the same ideas. Anybody else?
How do you strike the balance between unit tests and integration tests?
And so these techniques are going to be very, very unit test heavy. And it's actually kind of important to circle back on that even these unit tests are going to have a limited lifespan. Right? They're there to help you do the factoring. So in this case, this is been for a very unit test driven, very isolation way of doing it. And part of that goal is once you've broken your seats, and once you have clear definition of responsibilities modules, it might make sense to actually go back and switch the integration testing approach and actually kind of the unit test. But it's still not wasted effort. You're taking all that information requirements you can pull out of unit test, now start putting it into integration testing. So to take this example with my database stuff, I could have just as easily, because I have it like down. Now my database access for quotes is going to load quotes and get quotes. And I could just back that up with the regular database and calling tests and copy each time. But yeah, that would that's that kind of example. A lot of what he talks about with legacy code is it's going to get worse before it gets better. You're going to break it apart and make things a bit more messy, a bit more complicated to work with. But actually get the visibility and confidence to make changes to really serious refactors. Breaking seams and then, completely rewriting.
So for me, when I'm writing unit tests, a lot of times the test will very closely model the source code under test, like even the same file names and everything. But what happens is when I go and start making my refactoring and the test work, now code that I'm testing is starting to change shape, so I start changing tests. So I'm kind of wondering if maybe introducing seams is like a technique for maybe keeping that kind of interface the same while making those changes like comfortable enough to start making the tests model ongoing.
So what exactly is your question?
So I was just wondering what the seams. I understand the extracting. I'm just wondering what kind of high abstract level, like what the seams purpose are.
So if you're doing the case where you're closely modeling your tests after your code, this can actually be a good way to actually identify seams in, because couple of good ways could be what the unit test results are for. But even more closely, what the unit test results have to mock to get it done. Real good giveaway that you have a seam that you need to split or you need to break. You have a unit test, and in this one test you're mocking part of this thing, and another part of the test class you're mocking another part of this thing. Guess what? You just identified two separate responsibilities, and I can be willing to bet that they have two separate significance. So, I try to keep even when I'm just writing my tests at a very high level, but whenever I say that word, it's like floating close to the model. You actually look at a test and see if there's multiple responsibilities being called out in the test. And then you can look at the mocking to figure out where the seams need to go, where things are part of it. Test mocks one thing, other test mocks another thing, and everything's going to be up.
I found it kind of interesting in the last example when you would split up the utility seam file. Where by breaking apart things into the most basic functions, you can actually remove the functionality or separate the functionality of it. Like the random message or a list of messages to bring in random message is duplicating a standard library operator, random.choice, that's already built into the language. And it's pretty safe to say that something that's built that's taken standard library of any given language probably don't need to have your equipment.
No, that's very true. And actually, for this particular example, I intentionally pulled a lot of code samples from Stack Overflow. There's a couple other places where because that's what code's been working on. I didn't actually know for people choice when they telling me. And there's one point I kind of want to get back to that is I did not go through and optimize it. I didn't try to look for things like that. That's not part of safety factor. And one of the things you have to keep in mind when you use this technique is you kind of have to go into the code base with blinders on. You are going to find problems. You're 15 calls deep in Stack Trace. Yeah, you've already run into some problems. You need to learn to ignore a lot of that and focus on the keywords. Ignore that and focus on the code that you've isolated. And just extract from TDD that. This one just stops you from accidentally changing the code and stuff. Also, kind of getting back to like the value proposition, it makes it a lot easier to fit this inside and store your sprint. You know, right? Because you're basically self-scoping. And I found a lot of places, you know, oh, we don't have time to test one, I think this one. We're making changes to code, right? Okay. Show me how you change the code. Well, I come in here and I touch these 3 lines. Track that, please. Okay. Can you write a test for it? We'll just add, yeah. Write a test that proves 2 + 2 is 4. Okay. Good. It's lunch. We're good. Oh yeah. Keep going. I'll find this. But you know, that's just it. And instead of trying to start at like 0 or some test, no. Every change you make is an opportunity to add test scripts. So part of isolating it and working in basically that way forward is kind of something that pattern. You know, keeping value proposition alive. In his book, actually talks about it. It's like there's 2 teams trying to fight. Just one of them's going, yeah, just keep doing it. It's great. It's awesome. And the other team's like slow. So guess which team is going to have problems with production, right? So the ones that's changing things without keeping track of what it is they're changing, and have problems. It's slower. It feels stupid sometimes. Right? Sometimes you share your code, like I know I can do this better, but I don't.
So from your 5 steps, I saw that profit was number 5. So number 4 was go to 1.
Yeah.
You use profit.
If you haven't answered that question, I'm sure a lot of people in this room would like to know.
And then the follow-up line is, why is your computer getting sued?
Personal question?
No. Most of my computers are named after articles of clothing.
For that sounds great and everything, but for you have short period of time for a project, like it's LS or you have to work on it. Like how you proceed, you still use your steps, the same steps, or or you just drop the project because it's not going to be feasible to actually do it in the period of time that they ask you to do it. So how you proceed in that case?
So I probably should have added this to slides. Before you go out and read that book, there should be a preface added that says, at the beginning of the book that says, before you think about doing this, ask yourself if the code you're about to work on is worth saving. Okay. Now, that's not an answer just developer consultant data, but this is all about working effectively with code, and all these techniques is about keeping a code base alive. Bring it back and bring it back to life. There are plenty of times where the maintenance cost that this is talking about is way over what it would take to just rewrite the thing from scratch. And in those cases, just rewrite the thing from scratch. That's trust me. Yes. Yeah, of course you might get, no, this thing is absolutely vital. No, you really don't have time to do that level of writing. No.
Cost for starting over from scratch are often underestimated.
Yeah. I mean, there's ways I can talk about it, but one of the better ones, like if I'm working on, say, a microservices system, where services are broken down into small modules, it's probably going to be easier to just rewrite one of those than if I have a monolith, which is not even talking services, right? It's just making up database connections to file calls. Yeah, the cost to rewrite the whole thing is basically redo the entire product that we spent there, the entire time doing. I can't do that. But if it's redo this individual component that's responsible for this one thing, yeah, I'd like to say, we're just going to rewrite this because I'll be done in a sprint or 2, and I'll be 90% feature complete, and I'll be super happy going forward.
What if you did that and you'll set all your coworkers?
I'm really asking about that. So I don't have a good answer for that, and because I have, and I did, and not rolling. And look, at the end of the day, it is a bit of a risk we take on a refactor because there are putting yourself out there, and you could be wrong, you could screw up. Granted, these techniques mean if you do screw up, you have a really quick way. You know it fast, and you have a really quick way to revert, right? It's slow them up. So, but you give yourself out there. But every time it's come up in my professional career, and then I switch over to the new system, and it's so much faster and it's so much easier to implement features. And we have test coverage, and we have metrics. Onboarding new people is suddenly 10 times easier because I don't need to hand you a 40-page user manual just to understand where things are. You can just look at the test for the thing you're working on. That payoff doesn't come instantly, but maybe I've been lucky enough that I've always been able to enjoy it. But it kind of really goes back to when there's a high maintenance cost, you need to bring that cost down. And we have a high maintenance cost to your system. And especially with techniques that you can easily fit within your existing work, existing time allocating and changes. It's kind of so.
Any more suggestions? I liked your answer to the value proposition is like next time you ask me to do something or add a feature, it's going to take less time. I'll have to touch less lines of code. Any more justification suggestions that you have for that environment where it's like, go, 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 we don't have time, it's not worth it, I don't care about technical debt, I'm willing to accept.
How much time do I have?
Well,
Just talk to that.
The simple thing is like, the cheapest time to fix the problem is when it's first made.
Yeah.
The next cheapest is right after it's first made.
So you don't have time to test your get.
Yeah, so there's a couple basic ones, which I usually start out with, how are you making changes to the code today? Okay, like, you don't have testing, you don't have options, so I'm going to go back to my initial example of, you hunt it down and you find that there's this line buried way deep, and there's three threads touching up, and you're pretty sure there's a side effect going on here right now. It's like, how do you have confidence in making that change and you make it effectively? Because, what's the value proposition? Well, what's the value proposition of delivering a non-working product to the customer? How do you know, what is your current way? And sometimes I do get an answer, like there's this QA process, and that spawns a discussion. When it's like, we have a QA process is pretty good about catching stuff. It's like, okay, well, what about automating the QA process? What's the feedback looking at the QA process? Hey, how's your release looking? I mean, how many patch releases do you guys usually make? And these are metrics that some people don't think about tracking. It's like, my ideal number of patch releases per release, 0. The last time I was on, we actually managed to get there. And it was through doing a lot of this stuff. When I have a manager saying just go, and I don't care, just get it out there, not gonna lie, I sometimes gone ahead and just stop it. There's, like I said, it goes back to how are you making changes today? Because if you don't know what it is you're doing, how do you know that you've done it?
One last question.
Any advice for those extreme cases where you have, for example, JavaScript, HTML, and logic in the legacy code? Any advice on that?
Would you talk about something like PHP where you have it kind of goes back. So actually, with those, we're probably going to cover that case because you talked most about JavaScript Plus. But in that case, there's a couple different things going on. I kind of avoided it because even the Flask tutorials are like, yeah, you want to write HTML, you have to. But the very first things I can do there one single Selenium test around it. Right? Just simple one, make sure things are there. And then, just start breaking out the different languages to just templates and modules and components. And, if you're not in a template, the templated structure, and if you're doing like includes and all that other stuff to try to throw PHP together, it's going to be tough. And then you kind of take a step back and say, okay, what's the special possibility to do? Okay, this method is rendering this part of the header. This method is rendering this part of the body. And just kind of going back to going in with blinders and just not paying attention to the HTML and JavaScript at first, and getting the structure right controllers at that language. Once you get there and say break that down in quantum scenes, it's probably going to be a lot more obvious of how to present it to, say, templates. Once you have, say, one controller, one section, isolated from there, it's like, oh, these things are all using effectively the same snippet, templates, right? And then have controls with those templates. So, if you can't find the scenes there, obviously you can manage it. If you can't, keep the blinders on. Hold your nose, dive in, and you'll be able to get out of it. Or, I hear React's great.